about that.
No worries.
Cool. So I don't actually know if Soggy is planning on coming or Tio, but that's okay. We can run through a few things and then move them into. First of all, congrats on being V 0.3 of SimPEG. We bumped version because Gootney's NSEM stuff is now in. So because that breaks a lot of, it's a huge functionality change in the natural source stuff.
Okay.
So new version, which is awesome. So then the other major thing I want to talk about today was there's the geophysics papers, the reproducible research call for papers. It's due December 1st. And I was talking to Rowan about this yesterday, and there's for sure 2 papers I see all of us doing. So the first one being like wrapping up the SciPy stuff into a paper. So focusing on, like, I guess, all of the methods in a common framework. So what we did there is we had, there's TKC, which is the kimberlite pipe. And then we did simulations and inversions for a bunch of different methods, all using SimPEG. And the model is based on what you guys did with the interpretation papers. Yeah, so I'll put the link on Slack. I started just like sketching out a couple outlines for these. And like it would be good to get all of your take on that, as well to figure out like what kind of role everybody wants to take in this. Like I know Dom, you and Soggy have done potentially among the most, as well. I mean, T-Bone and Gootney have done a fair bit too, but in terms of integrating all of the things, yeah, if that's something you're interested in taking lead on, or if you have too much on your plate and want somebody else to take lead but you support, or like just kind of giving that a bit of thought.
Okay.
And also like what points you want to make, because I think we have a bit of freedom with that. Gootney, did you get that link?
Sure. Yep.
Cool.
So that would be paper 1, link for paper 1?
Yeah, so like what I was sort of, these are just thoughts, and like we can absolutely iterate on this. It's just sort of basically focusing on the fact that we're coming at this from a common framework, because it is a synthetic study, but then motivating like why we're using a synthetic. And then we can cite all these other papers, which I think is great. Showing that it's based in something, but the goal here is to address them all from a common framework.
Mm-hmm.
I think that would be really cool if we did that, if we kind of wrap the SciPy work that we did up a little bit better and get it into a kind of an official publication.
Yeah, I mean, because there's been so much work done there, and like a little bit of cleanup and sort of tying them all together, and I think it's like a pretty solid paper. Yeah, especially if we can point to the fact that this is like building upon a whole bunch of other work that was done with real data sets.
Yeah.
Yeah, absolutely. Actually, it could be a good introduction, right?
Yeah.
Say those papers have been done, but they were done on codes completely separate, and now we're going to bring in and say like we can do it all one shot.
Yeah.
Mm-hmm. Yeah, I like it. It's a good idea.
And then it's nice too, because we don't have to spend, like, we don't have to go too far in depth on the, geology or like any of that. We can build it up enough to get the point across and then cite the papers.
Yeah, so we don't get stuck in the details of geology. Womp womp.
Geology.
Okay.
So good.
What we were just talking about, Dougie, is these geophysics papers. 'Cause it's a December 1 deadline.
Yeah.
And so, we've done enough work that like we absolutely should be able to do it.
Yeah, I think we just need to put together.
Yeah.
So, should be fine.
I just put a link on Slack if you want to have a look. Because, okay, so we were thinking, I was talking to Rowan yesterday, we were sort of brainstorming 2 of them. So one being the TKC one, which is the link I just circulated.
Mhm.
And then one being more so on development practices, and in particular, highlighting a lot to do with testing. Because, yeah, there's a lot of good stuff happening in the testing that I think is worth explaining. And I think this call for papers is actually potentially very well suited for that style of paper. Because it's a bit of a different topic.
It's
On the code management side.
Yeah. It's a bit more of a meta paper, I guess, but I think.
I'm not sure, but like as I remember, there's more focus on Madagascar. I think because like they explicitly said like use Madagascar.
Yeah.
And, so that was something that I wasn't sure, like because their expectation is mostly seismic.
Yeah.
And
What is Madagascar?
It's an open source seismic package.
Okay.
It's a pretty standard. I think it's all mostly C++, although they've been trying to translate
I've heard there's a whole bunch of them.
Yeah.
But I've never used them. I'm not sure how it looks like. So.
Yeah. It's a reasonably old. Well, it's a very mature code base, and it is actually like pretty widely used.
Okay.
Yeah, but like I actually think that they'll be quite amenable to stuff outside of seismic. Like Mauricio, last time I chatted with him, he said, geophysics, they are trying to branch out to more non-seismic, so.
Okay. Yep.
Well, let's try.
They're seeing the end. You're seeing the end of oil? No.
Not for a while.
A few decades.
Yeah. Yeah, and so both of these, like we can have as many people as are interested in contributing to them on them. I don't see any reason to limit that because everybody's contributed stuff so far and will continue to. It's just sort of a matter of figuring out who's taking lead on each. And sorry, I was telling Dom, like for the TKC one, I'd sort of potentially see you guys taking lead if that's something.
Almost crying over.
Yeah. We'll all be involved, but if that's something you're interested in. If not, like that's totally fine.
Yeah, I'm interested. I
Okay.
need to start writing.
Yeah.
So. The hardest part is to start.
Yeah.
Yes. That's all.
It is.
Once you have one page or an outline,
Yeah.
then it's just going at it.
Yeah, let's do that.
And like I had a look, there's a lot of stuff in the actual sci-fi abstracts that I think we can just like take from recycle. So, hey Tibo.
Sorry. Yeah, that's cool. I would rather spend my time working on this than working on the back paper alone.
Yeah.
Just because the scope is it's more appealing to capture more people than.
Yeah.
Or it's just Mag. It's like, okay, I'm gonna talk to like 10 people.
Yeah. Well, and this I think especially following from the 3 interpretation papers, like this would just be a very cool.
Exactly.
Very cool.
Wrap up.
Yeah. So.
I agree.
So I know there's like a bajillion things going on, but I think if we have like a bit of a timeline and a few sort of goals for the next few weeks even, that'll help. Okay, maybe even for next week, if we have a bit more of an outline flushed out and just like topics that we feel are important to highlight, figured out.
Mm-hmm. Well, next week is consortium, right? So that's going to be hard.
Yeah.
And then SSEG right after.
Yeah.
Okay. Well, we'll work in this document at the last point. Just put ideas in there.
Yeah, just toss ideas. Let's maybe try and keep the outline like somewhat organized, but then we can just have like topics. And this is just like a smattering of ideas that we'll figure out a place for.
Okay.
Yeah.
Submissions.
Yeah. So Greedy and Thibaut, do you guys have, so we have the DC and the MAG stories in SimPEG tutorials. What's the status of the MT one?
We have not touched it since August, but I was thinking we were close to when like we had the notebook and like the things written.
Okay.
And if I remember well, I was leaving for Quebec, so Goodney told me he's gonna put that in for the SimPEG tutorial one, but maybe he was too busy, so we can take a look at it like because it's done. So.
Okay.
I mean, we've pushed it, I think, to the SciPy tutorials, but we haven't taken it from there and pushed it into SimPEG.
Okay.
Yeah. Okay.
So I mean, there probably is a bit of kind of cleaning and kind of reorganizing a little bit to get it into SimPEG, but at the same time, I don't think there will be a lot.
Okay. Yeah, if you guys could maybe push on that a little bit.
Yeah.
Because if we have those three done, then like basically most of the content and the examples are done for the paper. It's then just like tying it all together.
Yeah, no, I think I agree. I think that would be.
Goodney?
Yeah.
What? Hey, Goodney.
Hey.
So just to set it up, like I guess for me the best day to work on it will be the Friday. Are you usually at UBC Friday?
Usually I'm not, but I can be there Friday and we can just work on it. I think that would just be nice to get it done.
Okay, let's do that.
Kind of been on the agenda to move it, and this is a good kick in the butt.
Yeah, or even just say we work on it Friday, and if you cannot make it at UBC, just work Friday through Hangout.
Yeah,
that works too.
We'll figure that out.
Yeah.
Great.
Yeah, then I guess then the other paper, like I think a lot on testing, and so if there's ideas and things that you guys want to toss into that document, go for it and add yourself to the author list that's started. I think that's the easiest way to just like self-decide how much you want to contribute. So.
I like it.
Cool.
Cool.
Yeah, so do we want, like I know next week is consortium, do we want to set any like small deadlines for ourselves or?
Yeah.
So that's like all the companies that sponsor the group will be here for meetings all week next week?
Oh.
Yeah, so.
It's pressure for the boss, not really for. Well, some of us are giving. Are you giving a talk? Are you giving us?
Not sure.
Not sure. Stay in your office. Stay in your office. Well, you can see what we're working on, I guess. A recap on the LDAT's research too.
Yeah. Okay, well let's maybe try like if everybody takes a pass through both outlines, if you're interested in both or the one you are interested in, and like get some thoughts down, and then next week we can sort of hash out a bit more of a detailed outline. Because I know Rowan's keen to be involved, and I haven't chatted with Brendan yet. He might be, but his plate might be too full, so we'll see. You can ask him.
Sounds like second paper is more card for you and Rowan, right?
There's lots of stuff there that we've thought about and talked about before, but like absolutely looking for contributions from everybody on it.
Yeah.
So,
I'm not involved in testing or all that stuff, so I don't.
That's fair.
It's above my
Okay.
my pay grade.
Yeah.
Scope.
Yeah. No, that's fair.
But
Yeah.
paper one, yes, totally interested.
Sounds good. That sounds very good.
Yeah.
And then if there's other papers you have on the go that you want to shoot for, like I might try and shoot for a casing board simulation on them. We'll see. But deadlines are helpful for getting things done.
Right.
So.
Yeah, totally.
Yeah.
Mm-hmm.
Are there other things you guys want to go over? Stuff you're doing in SimPEG, stuff you need help with?
Yeah, actually, I'm working on the multi regularization for all the. What do you do for a mapping, man? Like, because now it's complaining, my dimensions. I have more model parameters in my mesh. I kind of need a list of mappings, basically.
Oh, wait. So what are you doing with your mapping?
So now I'm tackling the MVI. So I have 3 model parameters per cell.
Yeah.
Thank you. So regularization is easy. You can stack your operators.
Yeah.
But then all the mapping is done on the dimensions of the mesh.
No, but I think that's only for your regularization, right? So I was actually basically just using identity. Because you use a different mapping for regularization and your full model.
Yeah, you can.
That's right.
So I think that was what, I was basically using identity map. The regularization, I slice it. And then kind of you take the group, still your model space is 3 times bigger, but the actual space is the same.
Well, that's where the mapping complains, right? Because every time it tries to do the operation of your mapping, it looks at your model space and it's 3 times as large.
If you actually look at the multi-regularization, I increase the number of models. Because now your model is 3 times, say you have X, Y, Z, 3 times bigger.
Yeah.
And then it's let's say there are numbers of MX is NC. Then NC multiplied by 3, that's the number of your models. So, so you just generate identity mapping, which is NC number 3. So, I think I don't exactly remember how I implemented, but they're probably.
I basically had to overwrite right now. I'm just masking because right at the beginning in the model function, it's looking for the size of the mapping compared to the size of the model, and right away it chokes on them.
How are you creating the mapping? Are you giving it your mesh, or are you giving it number of parameters?
Number of parameters.
Okay.
So you just increase your number of parameters.
Yeah, but then I did that and then it crashed somewhere else. It's like kind of pushing down the road because eventually it's constantly asking for to do the transformation.
Yeah, I could. Yeah.
Oh yeah, it's because in the sparse regularization I do the mapping on each component individually, but now my mapping is 3 times n cell, but I'm only grabbing a third of those components, right? So.
Yeah, I'm not exactly sure how it's your sparse regularization exactly working.
But it would be nice if the mapping, if the mapping could act on individual model parameters, right? Because we could do that mapping. Let's say when we start doing connectivity and susceptibility, we might not want to do strictly an identity map on it. We might want to do a log on connectivity, but nothing on the susceptibility. Then
For a first pass, I had to do this with the casing example I did. So I wrote, unfortunately it's on this mapped branch, but I can do a separate little pull request. It's a projection map that all it does is just rearranges parameters. So you can give it, like, you just give it two sets of indices. So you give it the incoming indices and where you want those to be outgoing. So if you want only a third of your model, then you just grab like the top third and spit out the rest. Because what you could do if you want to use like the normal regularization is actually like just use 3 regularizations basically.
Yeah, it's not regularization a problem. The stacking, yeah.
It's the stacking.
It's the mapping, because every time it's trying to grab models, it's either too big, or if I make my mapping bigger, then when I grab only the 3 cells I want to do mapping on, then now it's too small.
Right.
Because mapping is not global, you know. At this point, the mapping should be tackling each blocks of model parameters.
Yeah. Yeah, down the road we'll tackle this with properties, and that is going to tackle the problem of doing like conductivity and permeability.
Yeah.
But right now, yeah, we can use that projection map, I think.
There's n models like on my multi-regularization parameters.
Oh, you do the n models.
Right. So I think in your case you should do 3, I guess.
Gotcha. So you're in the model function, right?
Right. Because like it doesn't care mapping is an identity map, so it's number of
Parameters.
model.
Yeah.
But you need to rearrange that. So I think inside that multi-regularization I do that.
Oh,
So
I see.
I was assuming like that a full thing. It's exactly like the assumption is that they are exactly in the same space, like the same spatial space. Like,
Yeah.
So let's say you have a number of models like 4,
Mm-hmm.
then your space, like the number of models nc by n4. So like in that way, I rearrange that and then kind of with the separate regularization.
Gotcha.
I guess. I don't know. My implementation was pretty.
Okay. I mean, that's all I wanted to know if that was a problem that was canned already, or.
Right, and then but I haven't generated like different mapping.
Yeah. Can you list mapping? Is it possible to list? Because if you can create a list of mappings, then it will be easy, right? You could just every time you do a mapping, you just go through all the list of.
Yeah, this is totally what properties is going to
do.
take care of. And you know what? We can actually, I think, push pretty hard to get that in like this week.
Oh, I mean, that's okay. I can do a workaround at this point.
Yeah. Because so you have a vector so you have 3 model parameters at every cell.
In every cell.
And you want to be able to treat them all independently, which is actually their own map.
Yeah, because eventually I'm going to go to like amplitude and angles, so they're not going to be even like, they're going to be spatially at the same location, but they're not going to be same quantities at all, which goes towards like connectivity, susceptibility. And,
Yeah, I think what I was doing, I was using property map before, which was trying to change, I guess. But I actually have a different mapping for different parameters.
Yeah.
But I'm not using that for my inversion.
Okay.
So for 4 problem,
Only for the 4.
so there's no problem. You can use like conectivity or like you can set whatever that as your model parameters. But in the regularization part, I just compute the gradients and the smallness and stuff, and then just rearrange. So because it doesn't necessarily need to know what my formatting was. So if you're just imposing your regularization on exactly your inversion model, then you don't quite need that.
Identity map.
Yeah, exactly the same mapping that you used for 4 problems.
And you should be able to provide, you should be able to provide 3 distinct mappings to the regularization so long as you define, like I would just define a regularization on X, Y, and Z, sum them up, and then treat them each independently. So each one can take its own mapping.
Okay, how do you do that? No, I totally agree with you, because right now we're just stacking, right? We're creating a big regularization function that is just like a block. It's a block diagonal.
Yeah.
That's what you're doing. Well, that's what I'm doing in my code, but yeah.
Yeah. So what I would do is actually define each one. Right now we don't have a great way to do this. We will soon. But what I would do is in your 5D, just sorry, phi m.
Yeah.
Just define like phi x plus phi y plus phi z, and just define each of those independently inside your regularization, and then that'll make it easy. You can then define a mapping that goes to each. So like it's a custom regularization right now is how I would say.
And stack it after.
Yeah, you don't even actually.
All your dimensions will need to fit, right? When you do the solve, your phi d size has to be the same as your phi m size.
Depending on how, like, but I think the current implementation you stack it because we're generating full W. Anyway, like stack or either sum that up.
Yeah, you could sum them too, but I would try and do it so that they're like composable pieces.
Right. Yeah, you can just rewrite that W functions. Yeah, I'm not exactly sure because like how it's structured now, it kind of forces you to generate the W and then evaluate it. I think that's probably how it works. I'm not exactly sure. I need to have a feed.
Yeah, we don't actually. I think when we rewrote it, you shouldn't actually. We have the functionality to form the full W, but I don't actually think we form it in most cases.
No, I think we formed it. That's how the regular position works.
Because what we've talked about doing, and this isn't implemented, is making just composable objective functions, so it doesn't matter. Like you can just sum up a whole bunch of things, which will totally help resolve this problem. Because then you can treat each piece like completely independently. But we're not there yet.
That's okay, yeah.
Yeah.
Yeah, because if you look at like the Tikhonov regularization, all we do is eval small, eval smooth, and eval smooth 2. I'll share this with you.
Which branch are you in? Sorry, oh yeah, okay, yeah.
It should be like all the way to
641, yeah.
Yeah.
Oh, okay. Yeah, no. Right. That's true.
So that's the way I would suggest implementing it, because this will translate much better to down the road when we actually start tearing this apart and making a composable objective function. Like it already is composable.
Sorry, which line are you working on?
So like this is pulled from dev.
Yeah.
So this is just looking at the Tikhonov when we eval it.
Yeah, you don't from W, yeah. You
Yeah.
just add the 3.
Yeah.
Sure. Huh. Just realized something. But when you're talking about summing, like in this case, eval small, for instance, if you don't stack, in this you have 2 model parameters. If you don't stack, eval small is too short. It's going to be too short for your problem, right? For your global problem.
So what I would do, because okay, which way is it going to be too short?
It's going to be too short on the model side, right?
So what I would do for that is essentially just do this equals, and so then this takes a or this is itself. So you can define and then like similarly for these guys, each of them takes their own
I got you, yeah.
and what mapping you want to potentially use, and I'll put this on a pull request. This is specific.
Yep.
The mapping then that I would use is.
Oh, and it's just gonna spark it. It's gonna
Yeah.
push it in the right place.
Yeah. So you
And
just
then-
say grab these indices, work with them, do a thing. This one takes these indices, do a thing.
But then how does it going to cycle through all of them? So basically, let's say you have two model parameters, you're going to give it two regularizations. How is it going to do that twice? So right now I understand you want to grab this mapping, it's going to take your regularization and push it to the first block.
Mm-hmm.
And how is the second operation going to happen to grab the other one and push it to the second block?
Oh, because so you have X, are we working with X, Y, and Z?
One component, WX, that's one.
And then when you say the second one, that's WY?
Oh, no, I thought you were talking about the smoothing. Yes, that's it, XYZ, yeah.
XYZ. So then this one just takes a different mapping. Do you want to, we can sketch this out and maybe see if, because like what you want to potentially do is you have, like your model basically is a vector where you have M1, M2, M3, right?
Yeah, regardless, yeah, right.
And these are each vectors.
Exactly.
So then what you want to do is have three mappings. One that basically just is like, you do this, P1 times this, you get M1.
Yep.
And you do P2,
Yep.
gives you M2. And P3, get M3.
Yep.
So then these mappings, you should be able to pass like three mappings to your regularization. So that, and perhaps you just loop through your
That's what I'm
list of
thinking.
mappings. Yeah.
Exactly. So it would be a list of mappings.
Yeah.
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 When you come to
sum.
this, it would be exactly.
Yeah.
It's going to be a sum over all your. So we need a list of maps. And then if we have a list of maps, then the map can be the projection, but it can also be anything else, right?
Yeah.
It could be like a log or whatever. All right, we'll keep it on that burner for later.
That's really cool.
Yeah, I don't remember what I did. Yeah, it was probably stacking. All right. I'm not sure. I think I didn't actually generate mapping for each.
Yeah, but if it's an identity map, you can get around it. That's what I will do right now.
Like, in the regularization, I was just reminding myself that was basically the same thing.
Yeah.
Breaking apart. But yeah, if you want to be more general structure, like if you want to pass different mapping and stuff. So I was assuming like always my inversion model is exactly the same as the inversion model you set up for your core poly. Yeah, that was the assumption. Yes. But still, there's no problem of putting log magnitude even without the mapping through the regularization. We're just using different mapping for regularization for the first version. Yeah. Is that clear? No.
No.
So for example, like that was really confusing in the beginning because if you're using actually the same mapping for your for problem and your inversion, for example, say you're like inverting log connectivity, then you're putting the regularization in connectivity, not the log connectivity. If you're passing exactly the same mapping to your for problem and inversion problem. So that was really confusing. So if you're not passing any mapping to your regularization, then you're actually putting your regularization on your inversion model. And so that's what like sort of that's the default. That's what you usually do.
Yeah.
But like having the ability to put different mapping in the regularization allows you to put like sort of different bit of transformation of your in your regularization that you're actually like you're putting constraint on that space, which is a different space on there. So I'm not sure, but that was like really confusing.
Yeah.
Yeah, so like if you want to regularize on log conductivity, you don't want to pass your regularization and X map.
Right.
Yeah.
Right.
Yeah, so I'm not sure when is the case that we actually kind of put a bit of transformation to it. So that, and these are not actually quite using any mapping for regularization.
Yeah.
So I just usually put identity. That's how.
But if we only, like, let's say you want to do different scalings, right? It would be nice if we could at least grab the right model parameters.
Yeah.
Instead of having to index, or so if the mapping can handle grabbing this guy's correspond to this guy.
Yeah, I've got one called a projection map that does that. It's on a weird branch right now, but I'll do a short pull request on the dev for that.
Perfect.
Yeah.
Yeah.
Because it's a super simple one. It just forms a sparse identity and then shrinks it.
Perfect.
Right. Yeah, so I think having in mind is actually kind of important, because like you're not going to use exponential net types of things to your regularization.
But it's the same problem, right? Once we have the projectors, we can do whatever we want, and it's an open switch to experiment on stuff.
Yeah, right. But I think what my point was like that mapping that you generate for your inversion, you're not going to use you may not use that for your for mapping. That was one, but that was just. So you're going to use you're not going to use the same mapping, because like the for problem doesn't matter. Like for simulation, just so you know that it doesn't matter how you set it. It doesn't matter how you set it up. Like for problem, okay, in this part, this should go with conductivity or susceptibility and if so on. That you can just set it up, but that regularization really doesn't know. I think, and then with that projection matrices and stuff, it's upon your inverse problem. So it's completely separate, I think. Having in mind, that's actually that was making helpful to me.
Mm-hmm.
Otherwise, you need to think twice. Continuity as well in this mapping, which is not. Yeah, that breaking that might be interesting. Still not exactly clear how it would work. Because it's a 3D mapping and then it's stacked, or it's not like it's different from combo map, right? It's not mapping of mapping of mapping, but it's like
it's a list of maps.
Yeah, it's a list of maps.
And you iterate on that map, and then locally.
I could use, if we can do that, then I could use the same, for instance, for the linear problems, there are stacked dense matrices on top of each other like this, or 3 stacks. So if I can list through a list of mapping, then I can also project, I can grab only the rows that I need.
Mm-hmm.
If I only want to compute the X component, or the contribution from the X component, I can grab only that rows with that projector matrix.
Yeah. Right.
Because when you're evaluating once you get to evaluating the regularization, you're just adding scalars at that point. So you can either do it by stacking the matrix, or you can just do each computation and then sum them up.
Yeah.
So.
Is it exactly the same? Or
You would do the same operation, right? You would just grab a portion of your model space, do a calculation, whatever it's regularization or forward problem, and then.
Yeah, that's more. It will be more clear. Sounds good. Yeah, because I had to put some weighting for different models, and then I had to do it by manually.
Exactly.
Put some weighting functions for each model. But if you actually do it apart and then sum it up at the end, that's probably more clear.
More clear, yeah.
Yeah, and so where I think the regularization and the data misfit are going is that we'll just define an objective function that you can basically write out as the sum of any of these little composable pieces, and then multiplied by potentially scalars or directives. So what would be great to do is be able to write out phi d for mag problem plus alpha phi d for EM plus beta phi m, but alpha and beta are actually just directives. But you can just make that mathematical statement in defining the objective function, which I think would be really nice. So.
Yeah, and then those directives just apply differently depending on what your problem is. Yeah.
And then because right now, like when we define an objective, or when we define an in prob, it has to be a phi d plus one phi d plus one phi m, which is a bit silly. Because you want to, like, if you want to do a joint version, you want to add multiple phi d's.
Yes.
So, yeah, we need to release that constraint.
Okay. Yeah. But that's okay. That kind of answers a long answer.
Yeah, long answer.
Right now, we'll just hack it, and then later on, develop more general.
Yeah.
Sounds good.
Yeah. So which branch are you working on? I'll have a look. Sure.
Well, I'm working on amplitude. I wrote the amplitude inversion last weekend, and now I'm moving to MBI. But so I'm amplitude branch.
Okay.
I took your stuff, Sagi, and then just added to your stacking method. I just applied it to the sparse regularization.
Is it not working? Or, I think it may work. I don't know. Like for a simple problem.
Sorry, again?
It may just work if, I'm not sure, but I think I tested for I'm not sure that I tested for sparse regularization.
It will work once I kill all the error message for the mapping. I just need to override some of the stuff so that it doesn't choke on the dimensions, and then it'll go through.
Oh, I see.
Yeah.
Yeah, just I think that end models, that was only thing that you probably need to be a little bit careful. Because I think I put the default 2. My models. I have 2 models.
Oh yeah, actually, I instead of so you were doing a number of models, right? I'm just checking now the number of integers between what you put in as a model and the mesh dimensions.
Yeah, that's it.
And then I just integer move through it, which is probably not the best, but it works for now.
Okay. Yeah, that's good.
And Thibaut, I've seen you're pushing some MMR stuff.
Yeah, but it's going slowly.
Okay.
Just slowly making my way through it, but didn't find much time to do it, and like just making my way slowly through how SimPEG is written and all the self-dependency.
Yeah. Is there anything you want to go over or anything?
I haven't really logged yet. It's just a matter of how much time I found to put into that. But like when I have a problem, usually I'm able to find it in a reasonable amount of time. So
okay.
It's just a matter of making my way through. So, and if I really block on a specific question, like it's mostly based on DC, so I know the guy.
Yeah, wonderful.
He lives nearby.
Yeah. Well, Courtney, I think we can get the dev to master today.
But do we have a deadline for the static SimPEG paper? That would help to a deadline.
Probably to have. There's so many things to do.
Oh yeah.
Yeah, that's something that I want to do definitely. But there's some have to do.
Yeah.
So, yeah. Let's like I don't know. I think I may not have too much time around
Next to me.
before SCG.
Okay. No.
After SCG, hopefully I'm going to escape to Japan. Go to November.
Really?
Nice. Well, how long are you gonna be gone for? Okay. So he's just not coming back.
Yeah. Too much, too much.
Oh, man. Well, maybe let's like, if you're good with this, let's maybe try and prioritize the December one.
Yeah.
Those 2 papers. That's like a doable thing, and then we can see how those progress, and then bump up the static.
I have a lot of things for the SimPEG tutorial, like we have the empty with Udemy.
Yeah.
This boundary condition I need to finish.
Yeah.
Stuff or like the Python notebook I got for building MMR, which can basically be like build your own method with SimPEG.
Nice. That's super valuable.
Because like we cannot have everything in our every setup.
Yeah.
It's
Yeah.
an example of how you can like without implementing things in SimPEG, just use some of the SimPEG
Yeah.
matrices, etc. to build your own thing.
That's awesome.
So that's a lot of tutorial that I need to finish.
That's really exciting, Thibaut. Cool.
Build your own sandwich.
Yeah.
Not sure it's gonna be delicious.
What are you talking about, Simon?
Yeah, it will be delicious. And nutritious.
It's true. Nutritious, that's for sure. Yeah. So, I have a lot of hope that I want to do. Yeah, I'm not sure it's gonna happen.
You still on your down? Still on
No, Dan is fine. It's actually like that meeting's gone, so their time till December. And then I don't know, that's something that I don't have to do, so it's okay.
Extra curriculum.
Yeah. Most of it plain wave.
Plain wave.
It's an interesting problem. It's hard. Like,
So you do your side.
yes. It's-
Look a bit at the empty page I did. Like there were like some just an introduction for plain web. Like you're probably further away, yet, but
No,
just,
yeah,
just
yeah,
to check
yeah,
if we got the same notation.
Right. I'm not like doing MT part. It's
Yes.
just like more like the hard part is like kind of transporting to time and then thinking about like what's physically it is.
Yep.
And how it looks like in time. So yeah, the harmonic part is it's okay. No problem. But like there's a bit of interesting things. What's first?
Yeah.
So if you think about electron, like you do something first.
Yeah.
And then think about the either. So you first think, okay, there is like it's very philosophical things. Which is first? Okay, electrical field is first. Then upon that, you can drive magnetic field.
Right.
And then like it doesn't necessarily seem. So like depending upon your choice.
Yeah.
So,
They're different.
because like you define E naught.
Right.
And then that's your condition.
Right.
That's your boundary condition or whatever.
Okay.
So you don't need to define both boundary
Right.
conditions.
Right.
So like that's known.
Yeah.
And then that makes a change, right? That was known.
Yeah.
Then electrical, like upon that, computing magnetic field.
Right.
And then-
But there should be like an equivalence between them, right?
Yeah.
Well, the ratio it's going to be equivalent,
Yeah.
which is impedance, but the actual expression is going to be different.
Huh.
And then physical meaning is a bit different. So when electrical goes first,
Yeah.
that's more galvanic case. So electrical fields exist,
Yeah.
then it generates magnetic field. But when magnetic fields exist first, so yeah, it's a, and then like then you need to connect that in time.
Yeah.
Then you need to think about what was the initial condition,
Right.
which was first.
Yeah.
And that makes a difference.
Yeah.
And then it. So actually, the textbook kind of just start with E naught, H naught, known,
Yeah.
but not quite.
Not quite.
So if you want to like your math solution is fine.
Yeah.
Because both of them were known, but it's just not quite true.
Yeah.
So then like you need to delve into what was it first, and then because like here what Doug is trying, he wants to impose some physical meaning, not just mathematical equation.
Yeah.
Then okay, there's an electrical field.
Yeah.
In that, or find it even just simple case. Now you're going back on time.
I think I'm making some progress.
I'm sorry about that.
No, don't be. That's really interesting.
It's interesting, but it's takes
So,
Yeah.
take this.
Did you read the paper that Doug sent last night about the
Well, I haven't read it, but I'm going through it.
I read it quick. Yeah.
Oh,
Like
monopole.
people looking for a magnetic monopole, quantum
Yeah.
physics.
Look down there, good charge.
I know.
Well,
Like-
they're like saying like in space somewhere there might be monopoles, not like on Earth. Like.
I noticed there's a prof on the search at U of A who's been doing a bunch of stuff there. I didn't actually read that article though.
Mm. So yeah, they're thinking that if you have like a lot of heat, I guess you could produce monopoles.
Yeah.
Whether they were annihilated like with the poles really quickly.
Yeah.
So you could find a monopole, but chances are they're rare.
Yeah.
But stable. Whatever. That's what I understood from my non-quantum knowledge.
Okay.
Have a good day, man.
See you, Thibaut. Good news or anything else you want to go over today?
No, don't think so. Just trying to continue a little bit of momentum on the natural source stuff.
Sounds good.
Shorten that list of things that need to happen. I'm trying to update the plotting functions
Okay.
so that they work as methods.
Yeah. Nice.
Going. It's a lot of cleanup and kind of rethinking about stuff a little bit.
Yeah. Cool.
Boarding
And
it
then-
makes it critical.
And you're presenting at SEG as well?
Yeah.
Which day are you on?
Wednesday.
Okay, cool. Should be fun.
Good morning. Yeah, it will be fun.
All right.
Sweet. Yeah, I guess I'll catch up with you guys later.
See you, Dean. See you, Dean.
Yeah, see you. Thanks for this meeting.
Take care.
Yeah, you too.